Hi, my name is Megan Kiley, and today, first of all, here's my name and the date. So today is May 25th, and I'm going to be talking to you about feedback loops in the non-gravid female reproductive system. So just to give you an overview of the presentation, we're going to start with the relevant anatomy of the female reproductive system, and then we'll move on to the menstrual cycle and hormonal control of the menstrual cycle. So here's some of the relevant anatomy of the female reproductive system. First, here we can see the ovaries. So the ovaries are going to be one of the most important things we talk about today. So in the cortex of the ovaries, you have follicles that are growing, and then in the middle, or the medulla, you have blood vessels and nerves supplying the growth of those follicles. And the ovaries are important because they secrete both gametes and hormones. We also have the fallopian tubes with their fimbriae pictured here. So those will take the eggs after they're expelled from the ovaries and bring it into the uterus, or the uterine cavity. And then we also see the cervix here and the vagina. So what is the menstrual cycle? So females produce gametes in a roughly 28-day cycle. It can be from 24 to 29 days, but normally it's about 28. And we refer to these as menstrual cycles because they're marked by a 3 to 7 day period of bloody uterine shedding, which is known as menstruation. And so the menstrual cycle can be divided into phases based on events in the ovary, so the ovarian cycle, and in the uterus, so the uterine cycle. So here we can see on the top right of the image, they show the phases of the ovarian cycle. So first you have the follicular phase, in which the follicle is developing. And then we have ovulation, in which the follicle releases an egg when it's ready. And then we have the luteal phase, in which the follicle becomes the corpus luteum. It secretes some hormones, and then it eventually dies by apoptosis. We can see that the uterine cycle, which is dealing with the endometrium, so the lining of the uterus, undergoes a similar cycle, and it matches up with the ovarian cycle. So here, during the early follicular phase, the uterus, the endometrium, is undergoing menses, or menstruation. So you can see here that it's shedding. And then we have the proliferative phase of the uterine cycle. So in the late follicular phase leading up to ovulation, the endometrium is going to be proliferating or growing in order to prepare for a potential pregnancy. Following ovulation in the luteal phase, in response to progesterone that's secreted by this corpus luteum, the endometrium becomes secretory in order to prepare even more for a potential pregnancy. So hormonal control of the menstrual cycle is very, very complex, but it is under the control of a few different hormones. So the first is gonadotropin-releasing hormone from the hypothalamus, which causes the release of follicle-stimulating hormone and luteinizing hormone from the anterior pituitary. And then there's also estrogen, progesterone, inhibin, and anti-Müllerian hormone, or AMH, from the ovary. And so these hormones are specific to each of the phases their actions are. So we're going to talk about the specific phases of the ovarian cycle here. And you can see the image on the right shows you all four, like the breakup of the phases that we're going to talk about. So you'll see this diagram over and over again, focusing on each different window or each different pane. So let's start with the early follicular phase. So in the early follicular phase, gonadotropin releasing hormone from the hypothalamus will cause the release of FSH and LH from the anterior pituitary. FSH is going to cause tertiary follicles to start maturing, and in these trying to mature follicles, we have two different types of cells. We have granulosa cells, which are under the influence of FSH, and these will produce both estrogen and AMH. And then we will have thecal cells under the influence of LH, which produce androgens. These androgens get converted into estrogen. So the big picture is we have a lot of estrogen production. And estrogen does a few different things. So the increase in estrogen will first cause negative feedback on the FSH, the LH, and the GnRH, and this prevents multiple follicles from being stimulated to grow during this phase. We only want one follicle to grow. And it'll also stimulate additional estrogen production. So estrogen causes an increase in its own production by the granulosa cells, so it's positive feedback. And in response to the estrogen, after menstruation stops, the endometrium will proliferate in response to estrogen. So we can see all that in this diagram on the right here as well. During the mid to late follicular phase and ovulation, so starting with the mid to late follicular phase, we have ovarian estrogen peaking, which makes sense because estrogen causes release of more estrogen through positive feedback, and now we only have one follicle still developing, so the granulosa cells in that follicle will secrete inhibin and progesterone in addition to the estrogen. So estrogen here is actually going to switch functions, and so now it's going to cause positive feedback on the GnRH in the hypothalamus. So that causes a surge of gonadotropin releasing hormone. Now we have high estrogen and we have rising progesterone from the granulosa cells, and together those will enhance the responsiveness of the anterior pituitary to GnRH, which will cause a surge in luteinizing hormone, LH. So this surge in luteinizing hormone is really important because it'll cause that oocyte in the follicle to mature into a state where it can be released. So 16 to 24 hours after the LH peaks, we have ovulation. So ovulation is when the follicle in the ovary releases an egg. And so the follicle will remain in the ovary, but the egg, surrounded by a few layers of granulosa cells, will be taken up by the fimbriae and brought into the fallopian tube and then the uterus. So following ovulation, we just said that ovulation is when the follicle releases an egg and the follicle itself stays in the ovary. The follicle will undergo a transition and become the corpus luteum. So the corpus luteum is a structure that produces progesterone, estrogen, and inhibin. So progesterone is the dominant secretion of the corpus luteum. So progesterone combined with estrogen exert negative feedback on the hypothalamus and the anterior pituitary. So there's no GnRH, no FSH, no LH. So there's no follicle stimulation going on or follicle growth. And also the secretion or production of progesterone will cause the endometrium to become secretory in order to prepare more for a potential pregnancy. And then finally, in the late luteal phase and menstruation, so the corpus luteum has a lifespan of approximately 12 days, after which it'll undergo apoptosis. So we just said the corpus luteum produces progesterone and estrogen, so this, once it dies, this decrease in progesterone and estrogen removes the negative feedback on the hypothalamus and the anterior pituitary, which causes the release of GnRH, FSH, and LH, and this whole cycle starts all over again. Additionally, since there's no more progesterone because the corpus luteum has died, the endometrium will begin to shed, and that's the start of menstruation once more. So at this point, the release of gonadotropins once again starts a new cycle of follicular development. So this whole thing can start all over again, approximately 28 days after it was initially started. So here's a review slide just because we talked about a lot of different components today. So here you saw all of these individually, like A, B, C, and D on the past 4 slides, and here you can see them all over again. So just big takeaway points. So in the early follicular phase, you're going to have the release of GnRH, which stimulates the release of FSH and LH, which causes the production of estrogen. So estrogen is originally inhibitory, and then it switches to being positive feedback. So once we have that like a surplus of estrogen, we're going to also have a rising amount of progesterone in the later follicular phase. Together, those will cause a surge of LH. The surge of LH is what stimulates ovulation to occur. Once ovulation occurs, the follicle that released the egg remains in the ovary, and the follicle will become the corpus luteum. The corpus luteum will secrete progesterone primarily, and estrogen, and that progesterone causes the uterine lining to become secretory. It also, together, those will stop any gonadotropin release, so there's no follicles growing at this point. But in the late luteal phase, after the corpus luteum dies, then we will have less progesterone and estrogen, which will allow for the negative inhibitory effect to stop, and gonadotropin releasing hormone, FSH, and LH will all increase once again, starting the cycle all over. So those are the basics of the feedback loops that regulate non-gravid female reproductive system. So hopefully that was helpful. If you have any questions, please let me know. There's also a review sheet that will walk you through each of these phases in the ovarian cycle, so you can practice knowing what hormone has what function.